J'ai 16 classes. Je dois donner cours d'informatique à des élèves du deuxième degré, des 8-10 ans, ou à des élèves de 10-12 ans, et ainsi que à des élèves de la grande section maternelle. Mais je vais plus me pencher sur la section primaire parce que c'est un peu plus mon domaine. Donc je donne 50 minutes à ces élèves tous les 15 jours en demi-groupe dans un petit local avec maximum 13 élèves. Je dispose d'un matériel assez riche et varié, donc comme vous le voyez, 13 PC, un smartboard, 30 cartes microbytes, etc., etc. Et j'ai aussi du matériel personnel et je peux aussi en louer. Alors, mon support de cours, c'est un peu ma boussole. Donc, je ne sais pas si on sait le voir, non, ça, oui, voilà. Donc, c'est un Padlet qui reprend, en fait, c'est pour toutes les années. Ainsi, ils peuvent facilement se retrouver leurs cours et communiquer entre eux. Donc ils peuvent, les grandes sixièmes vont voir ce qu'ont fait les troisièmes et on peut ainsi se créer des échanges. Ensuite, après mon support de cours, j'ai également, pour chaque année, c'est chaque fois séquencé en 3 moments. Un moment de projet pour chaque année, de la programmation et un peu plus de numérique. Alors en troisième année, ce que je fais, c'est le projet First Lego League que j'appelle Junior. Les élèves partent à Ciné. Ils ont expérimenté les Lego Spike et ils les ont testés et ils construisent un projet autour d'un thème qu'ils vont présenter sous forme d'exposition là-bas. Ensuite, je les fais travailler dans Scratch. L'avantage, c'est que je peux faire des classes. On regroupe tout dans un studio. Chaque élève partage et voit ce qu'il a fait. Et moi, je peux les suivre aussi à distance puisque je ne les vois pas tous les jours. Alors, ce que j'aime bien aussi utiliser, c'est code.org qui, là aussi, me permet de faire des classes. Ils avancent chacun leur groupe et au bout des dizaines de leçons, les enfants, avec ce qu'ils ont appris, nous créent une petite animation. Ici, par exemple, ils doivent faire voyager un robot dans l'univers de Star Wars et voilà, ça plaît plutôt bien et les enfants réutilisent en fait ce qu'ils ont appris dans leur propre création. Ensuite, j'utilise toujours des robots comme Timeo. Je programme aussi en pixelaire avec cette application où ils apprennent à programmer une machine qui tamponne des cases, par exemple. Donc, ils font des motifs. Et plus du côté numérique, parce que notre programme FMTTM qui va bientôt arriver nous demande d'utiliser les images. Eh bien, mes élèves ont créé une sorte d'animation, j'en prends une au hasard, donc à partir d'une image fixe, ils la rendent animée, tout simplement. Alors le but, c'est pas de faire une image animée, enfin pour les enfants, oui, mais pour moi, c'est de leur apprendre à voyager dans les différents fichiers et applications d'un PC, savoir enregistrer un document dans le PC et pouvoir le retrouver. Et ici, ils ont toute la leçon qui permettent non seulement de réaliser l'activité en classe, mais pour les plus grandes classes, parfois, les plus grands viennent voir et s'essayent aussi et peuvent l'ajouter ainsi au Padlet, tout simplement. Enfin, au niveau sécurité, j'aime bien utiliser cette petite application qui est Interland et qui permet en fait d'apprendre comment éviter les mauvaises surprises sur Internet. Voilà, ça c'est au niveau de la troisième année. En quatrième année, on continue les robots, l'heure du code et tout. Et là, le plus grand projet pour nous, c'est Mooncamp. Alors, c'est un projet proposé par ESA et Zero Belgium. Donc, les enfants doivent imaginer une station lunaire pour de futurs astronautes qui iraient travailler plusieurs jours. Donc, il faut créer des endroits de vie, il faut les rendre autonomes. Donc, certains ont créé euh, si ça veut bien descendre, une serre, par exemple ici aussi. Il y en a qui ont créé des salles de sport, des tapis roulants, parce qu'il faut se maintenir en bonne santé. Il y a différentes perceuses aussi. Voilà, donc c'est extraire la glace qui est au sous-sol lunaire. Et en fait, ce qui est intéressant, c'est que les enfants ont dû se renseigner d'abord, c'est la méthode du projet, la démarche scientifique. Ils ont dû d'abord s'informer pour voir quelles étaient les réelles conditions sur la Lune, et puis imaginer sur un logiciel qui s'appelle Tinkercad. Tous ces projets sont envoyés à l'ESA, voilà, parce que en même temps, c'est un petit concours. En cinquième, la First Lego League passe dans la cour des grands. Donc là, il y a un concours de programmation. Mes élèves se rendent à Sydney et vont, voilà, vous voyez apparaître les codes. Non seulement il y a un jeu du robot, donc la mission du robot, ils doivent programmer un robot pour réaliser des codes, mais également ils devront aussi présenter un projet. Bon, le pad est très chargé. Ah voilà. Donc on voit ici un peu leur code. Et si je vais un peu plus loin, eh bien, il y a leur présentation, leur nom de groupe. Ils avaient trouvé leur nom de groupe, les graines d'énergie. Donc voilà ce qu'ils ont fait. J'aime bien la petite application Computit. C'est pour démarrer la programmation en texte. Alors, ça peut être écrit en français, mais en fait, ce que j'aime bien, c'est la façon dont c'est écrit, avec cette ponctuation étrange que sont les parenthèses, utiliser la tabulation, donc, et les répétitions. Donc, c'est un premier stade. Pour le moment, nous voyons, comme en quatrième année, on fait une grosse révision de ce que c'est que l'impression 3D. Et ici, on fait un concours de la plus belle pièce qui sera imprimée par l'imprimante de l'école. Donc c'est tout début, donc il n'est pas encore complet le pad. Nous avons aussi fait du pixel art pour les cartes de nouvelle année. En sixième année, c'était la mission Astropie. Alors là, on est passé au code Python. Les enfants ils ont réalisé la mission 0 qui était d'envoyer un code en Python, donc une image pixelisée sur le Sensei Hat d'un Raspberry Pi qui est dans la station spatiale internationale. Donc ils sont tout fous parce que leur programme va tourner 30 secondes là-bas et ils auront leur petit diplôme. Alors on travaille un peu plus la programmation avec McQueen et on tente d'aller vers l'IA avec les caméras Unskillens. Donc on a déjà commencé pas mal de choses. Voilà, on continue notre petit parcours. En sixième, c'est plus libre, comme ils m'ont déjà eu pendant 4 ans. Ils ont le choix des différents projets en fait. Voilà, alors mes points forts, en fait, au départ, c'était des difficultés, donc des élèves très motivés qui partaient dans tous les sens. Il a fallu les canaliser et leur donner des choses intéressantes à faire. Mais pour ça, j'ai eu beaucoup d'aide de l'école numérique pour le matériel, la Scientothèque pour les bonnes idées, Codowani, du Lab Technobel, etc. Désolée si j'en oublie quelques-uns. Ce qui était intéressant à faire, c'est que je reste une institutrice primaire et je ne peux pas faire autrement que de faire des liens avec le cours de maths ou voire de français. Et donc, c'est quelque chose que j'aime beaucoup faire. Alors les parents, au départ, c'était pas gagné parce que c'est des heures d'écran, les écrans, c'est pas bien. Et là, ils commencent tout doucement à être intéressés et même reconnaissants. Ils se disent, bah tiens, c'est intéressant parce que c'est l'avenir après tout. Alors, un de mes points faibles, c'était que je ne suis pas informaticienne de base, je ne suis que institutrice. Et c'est avec mes élèves, avec leurs questions, qu'on va chercher les réponses et notre cours se base sur un type d'échange. Donc, parfois, je ne savais pas répondre tout de suite à la question. Et puis, 2 jours après, l'élève qui avait aussi cherché comme moi a trouvé la réponse. Donc, ça, c'était aussi intéressant. Par contre, il reste encore des points d'intention. Le fait d'avoir toutes ces classes, c'est parfois très compliqué. J'ai peur de m'y perdre. On a un tout petit minuscule local et pas beaucoup d'heures. Là, on va tenter avec la direction d'élargir un peu tout ça. Je n'ai pas encore ou peu d'interaction avec les collègues parce que je trouve qu'on pourrait exploiter ça dans les heures de classe. Je reste dépendante du matériel, c'est-à-dire s'il y a une panne de Wi-Fi, un robot qui n'a pas bien été chargé, je dois absolument avoir des solutions de rechange. Ça, c'est quelque chose auquel il faut veiller. Il reste encore des familles où les écrans sont bannis, donc c'est dommage parce que, en fait, ce pad, ils peuvent y accéder via la maison. Et donc, ils sont libres et je dois les rendre le maximum, le plus possible autonomes parce que tous les parents ne savent pas aider leurs enfants et j'aime bien que les enfants présentent leur réalisation aux parents sous forme d'échange pour montrer ce qu'ils font et pour montrer que les écrans, c'est pas que être un zombie devant Fortnite ou Enzo Wort. Et voilà, je vous remercie pour votre écoute.
The heroes are 1, 2, 3. Great.
Good morning, everyone. I'm Tom from Dwango. And Dwango is a non-profit which was started at Ghent University by some PhD students of the computer science faculty because they saw that everything they learned during their bachelor's and master's and PhD was actually nowhere to be found in the curricula in primary and secondary education. And that's why they started this nonprofit to be able to create teaching content for both primary and secondary education about robotics and AI. This is just a screenshot of our website, which shows all the teaching topics we have. I'm just showing you this as an overview. So it's all in separate topics, and within the topics you have specific learning paths aimed at teachers so they can go through the content themselves and learn about how they can teach it to their students. All our teaching materials are based on these 5 core ideas. So our content, or we try to make our content innovative. What does that mean? We don't just take stuff from the internet and massage it into formats suitable for education, but we actually try to create content about topics for which there isn't a lot of content. Then it's also research driven, since we are still closely tied to the AI and robotics research group of Ghent University. A lot of our topics are actually interlinked with what's actively being researched in AI and robotics. We also try to be inclusive, so we believe that computer science and AI, a basic knowledge about that, is useful for everyone. So we embed those technical subjects into a lot of different contexts that can appeal to a broad audience. And that's in those contexts we also aim to make them socially relevant. And beyond that, we don't just focus on the technical part of AI and robotics and explaining that, but we also look into what the impact is of those technical things like AI systems on society. Here you have a short overview of the topics we have about AI, since this is in the context of European AI Week. These are all the subjects we have. It ranges from the first 2 years of secondary school to the last 2 years. So for example, the social robot project is for the first 2 years, and the KICS project about climate change is more for the last years. Now, we have a lot of material, so I just picked a few things out to show you here as a small demo to get an idea about what the content is about. This is an example of the social robot project. In this project, students can build and program a social robot that interacts with the environment and with the people around it. It's completely it's a complete set, so you can just get the set and they can learn how to build it, how to program it. And then there's also some context about the effects of social robots on society. So here are some examples. You can see an Iron Man robot or just some robot out of Minecraft, I think. So they can be creative, and as a result, it also attracts a lot of different students because they can do a lot of different things. They can also program it both graphically or in C code, C++ code. It's in the browser, a bit like Microbit, for example. So you just don't have to install anything. So we also create tools to make it easy to use it in the classroom. It's also all completely free, so you can just use it whenever you want. This is another example. It's a next step beyond the visual programming, and it's an example of our Jupyter notebooks. So the Jupyter notebooks are live online programming environments in which you can intertwine code with text and explanations. Here you can see an example of how they can program a convolution. It's like one of the basic fundamental aspects of what object detection AI systems use. And we have notebooks about that to explain what a convolution is. And they can then use that, for example, to do an edge detection on an image. Beyond that, you have here a video that uses then an AI system for object detection that is also using these convolutions. And this system is combined with a conveyor belt. This is for our AI in agriculture project, where they have a system. They can put fruit or vegetables on the conveyor belt. They pass by a camera, and the camera detects what kind of vegetable or fruit it is. So that's one of the projects we have. All the projects I've shown now are more STEM oriented and technically oriented, but we also have subjects beyond that. For example, about language technology. We have content about, for example, chatbots, which are very popular right now with ChatGPT and other chatbot systems. But in our system, they actually start from the bottom, and they can program a very basic chatbot, and then they learn the different steps to make it smarter and smarter. And they can also apply it themselves, so they program the chatbot themselves, which is very interesting for them to learn about how those things work. And then we also have things about sentiment analysis, where, for example, they can put in a review of a video or a movie, and then the system tells it, is it a positive or a negative review or a neutral review? And they also have different steps they can go through, from just picking the sentiment of the different words and then seeing how many of each word are in the review, or then using a more complex system that is trained based on lots of data, like is mostly the case with AI systems right now. We also have a book for teachers with a guide on how to do this in their classroom. So we have different teaching materials that are on our website for free. And for some context, we also have like a teacher manual, which is not just on the website, because students would be able to download it, but you can just send a mail and then we can send you the PDF, or you can buy the physical book if you really want to. And then going even further beyond the technical stuff. So we have technical stuff in different contexts, but we also have content about how to, or what the effects are of AI and robotics on society. And this is an example of a card set we have with some sentences which state something about robotics or AI. For example, here there's a sentence about cuddle robots that could be used in care with elderly people. And then the task is to look at this sentence from different points of view. For example, from the patient, do you like it that the person that should be there to hug is replaced by a robot? Yes or no? Or from the caregiver, they might not have time to hug those people, so for them it might be an advantage. So we have a card game about that, and we also have different teaching materials to show the importance of thinking about those systems in society. And that was my short overview with some topics that we have teaching content about. These are all the people that are involved in Dwango right now, so who create all the content and put them on the website and create all the tools. And you can find them all on dwango.org. So thank you for your attention.
Thank you, Tom. And to follow on this, I will present a couple of activities that we have designed at La Scientothèque in the last year to teach young people about algorithms, AI, and robotics. The first one we wanted to talk about is the Fetch Bot. So it's an activity that we designed in collaboration with the European Spatial Agency, and its educational program is Zero. And the inspiration comes from the Mars mission, where the goal is to explore if there is life on Mars. So currently there is a rover who is taking samples of the soil on Mars. So the rover is called Perseverance, and it's not able to go back on the Earth. So later there will be another robot that will need to be sent to Mars to retrieve those samples. And probably that rover will need AI, things like image recognition, to be able to find those tubes on Mars. And the activity we created allowed to mix different components. So there is an image recognition part where the rover has to find those tubes. There is a robotics part where the children have to design a robot. And then there is a programming of the robot so that it's able to move around and to find tubes on a terrain. And we wanted this activity to be fully open source, to be financially affordable, to be simple to build, so accessible to kids from age 10, and to be programmed either using block language, such as Scratch, so for kids between 10 and 14, or in Python for kids with a more advanced level in programming. So everything is online now on GitHub, where the set of activities are fully presented. And I'm just going to give a quick overview of how that works on the main components. So the first main component is how to train a model to recognize images. And for this, we can use the Teachable Machine from Google, which is a very simple interface on the web, where you can teach a model to recognize images. So you simply take images with the webcam. You define the classes of the things that you want to detect. So in this example, we have two classes, one with the soil, one with the tube, so where a tube is present on the soil. And after the training, you can check if the model is good enough for what you want to do. And here we see on the right that the model detects that there is a tube on the soil, so that it correctly detects tubes. For the programming part, so we introduce children to algorithms. So here is an example on the left side of what the algorithm should do. So the first step is to load the model that was trained on the Teachable Machine. And then there is a loop where we take an image from the webcam. Then we predict what kind of class corresponds to the image. And if the class is tube, then we have a sprite in Scratch saying that it found the tube, and otherwise that says, I don't see anything. And to show you how simply that can be implemented in Scratch, here is a Scratch program that does exactly what these algorithms defines. So there is a block to connect Scratch to the Teachable Machine and retrieve the model. And then we have a loop where we have a block that gets an image from the webcam, predicts what's on the image, and then just a block to say what is recognized by the model. A small demo of what that gives in the Scratch interface. Once we run it, we have the image from the webcam, which is presented in Scratch. If there is a tube, the sprite here, which is a rover, says, I found a tube, and otherwise, I don't see anything. For building the rover, there is a very nice kit called the CamJam Edu Kit, which is around 20 euros. And it comes with 2 wheels and motors in a box, and the box can be used as the chassis. So here is an example of how it is. We took the wheels and the motors out of the box. We glue them on the box. And then by putting a Raspberry Pi inside and the camera, we have our working robot. You can also be more creative. So there exist open access designs for 3D printing. So we can 3D print the chassis. That's another activity that can be done with the children. Or you can create your own kind of chassis using a plank of wood, for example. So there is a lot of creativity that can be given to the children. And we tested the activity during a summer school that we did last year. And at the end of the summer school, the children presented their projects. Here is just the beginning of the video to show their enthusiasm that they had in doing the activity. Dressed as scientists.
Pour ramasser les débris, nous avons construit et programmé le robot afin qu'il explore le sol martien et qu'il différencie les tubes à récupérer des autres débris. Voici un schéma du robot. Pour fonctionner, Fedbot a besoin d'une caméra pour voir et reconnaître les débris à récupérer. Des roues et des moteurs pour avancer. Une carte Raspberry pour lancer le programme. Et de batterie pour alimenter le tout. Voici notre programme.
So that was, yeah, to give you an idea of the enthusiasm that the children had, and the activity had a lot of success in showing the kids how they can train an AI model to recognize images, how they can build a robot and have it move around. And the other set of activities I wanted to talk about are part of a project called AI for Inclusive Education, which we started in 2022. So it's a collaboration between La Scientothèque, Collective Up, and FARI, which is the AI for the Common Good Institute in Brussels, and supported by DBSF, Digital Belgium Skills Fund, and BOSA, which we want to thank for their support. And the goal of the project is to design a set of activities to introduce children and teenagers to AI, which is available both in French and Dutch, and ethical and technical in scope. So last year, the two main deliverables of the project were a set of 6 activities of 2 hours each for the introduction to AI, introduction to algorithms, introduction to machine learning with the datasets and predictions, and then programming, also components, so how to train an AI and use an AI in a program, and finally, an activity on ethics and bias. And the other main deliverable was the first conference on AI and education for young people, which we did in November at Bicentral, and which gathered together 20 organizations on education from Belgium. And this year we'll continue this project by designing a set of new, a set of 5 new activities, which will be on the topics of bias, misinformation, intellectual property, data privacy, and the Sustainable Development Goals of the UNESCO. And with the goal of continuing to mutualize the effort on that topic in Belgium, and to link the content to existing pedagogical framework, and in particular, the DISCOMF framework from the European Commission.
Like this? Yes, okay. Good morning, I'm Liliana Carrillo, I'm the founder of Collective App. Here I added some print screenshots of our website. So we have several projects. We typically work with young people, and we have the tendency to do also to work on inclusion, meaning that, for example, we work with kids with disabilities. It can be autism, it can be hearing disabilities, sometimes also mobility. And apart from that, we always work with digital technologies and with methods. For example, we have a project related to working on artificial intelligence, fostering artificial intelligence at the schools. And there we have also created materials for teachers to work, first of all, to understand what intelligence artificial, what artificial intelligence is, in very easy terms. So we have their materials to download. And then on the other hand, we also have a technical guide regarding the use of learning ML, one of the Scratch tools related to machine learning, and using it actually in the classroom to understand how machine learning works in easy way. I mean, it's not really programming, it's actually moving Scratch blocks and uploading some photos or uploading files, and then understanding how an algorithm needs actually data. It's trained actually with that data, and then you can use that train model actually to predict a certain topic. So you can, for example, see that we added a bias lesson there, that we are actually also working with Janelle and with Patricia. And in that lesson, we work tackling also the bias in AI, meaning that, for example, we work on gender balance, and we work at this with sometimes with kids, but actually mostly with adults. But then let's say that if we move on, one of the projects that we work really, really very closely with kids is this one called Youth for Bauhaus. So in this one, we actually use Minecraft as a tool, the game Minecraft, as a tool to co-create spaces, urban spaces with young people, and to recuperate places actually in the city. So we are working right now with 4 cities, and we go, for example, in Ghent. One of the cities is Ghent, and there are more or less a list of 30 spaces that are kind of like called gray spaces, so spaces that are not used in the city. And then what we do is we work with the young people, and we do co-creation workshops around urban planning. And then after all these workshops, we actually work with Minecraft to visualize what the kids have been doing. So the result is a 3-dimensional model in Minecraft of a specific place that they have redesigned together. And I want to show you a video. It's a very nice, it's an European project. It's an European project funded by Erasmus Plus program. Let me see. I hope we can see it here. The sound and spaces in the city together with the young people and for the young people. And we do it using the game Minecraft, but we always have in our vision is to create these spaces that are inclusive, sustainable, and beautiful. Youth for Bauhaus is a European project funded by the Erasmus Plus program. We did a study of how many educational goals could be fulfilled by playing Minecraft in a specific way. And then seeing this game that is 3-dimensional, then I made the click. Okay, we can use this actually for co-creation of spaces. I started to realize this can be bigger, this can be actually done in many cities and learn from each other. And at the end, I got engaged with 3 organizations to work with 4 different cities.
We were on a tour around the city. They were explaining the history to us, and I thought it was like really interesting, you know.
And
because some places are a bit deserted, there's no life, it's places people try to avoid, and we're trying to make it a place where it will be bustling with people and full of happiness and life.
And what we are trying to do with the project Youth for Bauhaus is trying to recuperate those places. It was very important to also have students with special needs. From older perspectives, we could actually improve the places because they are also telling us how to make it inclusive.
We have the Minecraft version of the actual space in the city, and we think about the community, what the community needs.
We have to imagine how we would like it to look like in the future. Everyone had like a really great ideas. I think I learned a lot. It gave me like a lot of experience, problem solving.
It feels good that there is a small chance that what we are working on, it will be true. It will come true. It will be built here maybe, and we hope they listen.
When I saw the young people presenting their ideas on that last day, that was like all I have worked for, to see those ideas and the young people empowered, showing what they wanted to do with the city.
I'm extremely glad that I had the chance myself to come to Belgium and work with all those amazing young people.
Youth for Bauhaus is to include the youth, us, and not only let the adults choose what happens.
It's about the future of the young generation and how we want it to be.
If you do it in multiple cities, multiple kids can come together and multiple places will become beautiful. But Ghent is only a small piece of our world, and the whole world needs to be beautiful, sustainable, and so we need the whole world of it, not just 4 cities.
I want to continue this work and the co-creation process with young people in as many places as possible, and have new cities involved in the project, new organizations, new schools, and get to think about those futures and the futures that we actually want for our youth. Yeah, so this is the project. And now, yes. So this is the project Youth for Bauhaus. So we use games. We do it in a super nice way. The kids are engaged, and it's not only fun, but we are actually doing something good. So it's a really great combination, and we should be using more digital technologies in the classroom, as you saw also from our colleagues. So this is not the only way. There are many, many ways. So it's an invitation to continue doing the same. Thank you.